going. Steve, you want to kick off any updates?
Yeah, I'm just in the middle of actually running a test. It's just actually finished this second. Yeah, so what I'd done was, so I'd split all of the images into like 13 tiles, which obviously, like I ended up with sort of my data set was about a third bigger than the guy with his 7 tiles. And so when I submitted with that, I was expecting to get better results or whatever, but they ended up worse than what he had. But then there's a few reasons I think for that. Like, well, for a start, because the data set's bigger, and I was only training for the same number of epochs as he'd done. So I would probably need to like up the number of epochs to get a better result. But then I switched, like last week we'd been talking about sort of changing the data set so as it would like balance the categories. So I changed that. So I balanced the categories just by any category that sort of was missing images or didn't have enough images to make up a balance. Those images would just go in a repeated number of times. So I ended up with a training set that just had like one category for each of the defects, and then like a 5th category for any tiles that had like multiple defects on the tile. So I submitted that and ended up with pretty bad results from that. But so then I was looking at it. But when I split my images up into tiles, I was working out the stats using the guy's formula or whatever, where he calculates like the stats based on the tiles that he's creating. And like the stat values I was getting were sort of quite different from what he had. So I tried again with a balanced data set, but with his stats, and the results I got were a lot better. And then I remembered like the other week we'd been talking about it, and Reckle had been like sort of saying, why not use sort of the ImageNet stats? Saying like that's like the ResNet is the encoding part of the UNet. So I changed to using the ResNet stats, and the results got even better. So now I've just added in extra data into the training set. I've taken out the texture data, so I've put that back as a separate category, and I've added in a category for sort of negative images, but negative images that don't sort of go wrong. So like they're pure sort of negative images that don't have any mask. So I've now got 8 categories. So I've just trained on those, and as I say, it just finished this second, so I was just about to submit that to see how it does. But in terms of balancing the thing, it hasn't actually helped me yet, but it may be because of the fact that I've got these other problems. So hopefully I'll find out in a couple of minutes or whatever. Is it actually better or not?
I see. And what loss, sorry, I had to step away for a few seconds. What loss are you using for this one, Steve?
Oh, I'm just sticking with the standard
Cross-categorical
cross entropy loss. Yeah, so I gave up on I gave up on the fancy losses because I wasn't getting any better results with using any of them. So
yeah.
At the start of the week, I'd taken a look. I saw that for the competition, there's a web page or whatever with links to, I don't know what it is, like maybe the sort of the top 10 people or whatever. So I'd started to like look at those things, and there's like quite a lot of interesting stuff in it, but I haven't had a chance to follow it down yet.
Yeah, I once we go around, and then I can share like I created a document from that link of cut and pasted many of the, mostly focused on top 10, but also the most efficient. And then I picked some random 1 or 2 more, and we can talk to some of those that I saw what they're calling out, and then maybe that'd be a good thing to dig into, and kind of we can divvy up if people are up for it, the different pieces, and either try them out or at least try to explain what what those techniques mean. Anything else, Steve, you wanted to add?
No, that's where I'm up to at the minute. As I say, I've just one of my experiments is just completed, so I just need to submit the results here. And it's the one with sort of uh, a proper balance thing with proper categories or whatever. So hopefully it'll do better than what I've had before.
Steve, I had a question. So when you use the ImageNet stats,
Yes.
I think the values are like the mean is 0.4 or something like that. Like you have a mean per channel. Right?
Yes.
And I was looking at the PyTorch documentation and I saw that there's one thing it confused me. It says the images should be scaled from 0 to 1. So did you divide before applying the stats? Did you divide the images by 255?
I don't know actually. Yeah, because I'm just relying on the sort of the fast AI
Okay.
loader or whatever. So I didn't explicitly go and divide them by 255. Yeah, so I just went with the whatever fast AI is doing to them.
Yeah, because I was doing something at work and something similar, right? Like just all transfer learning, and then when I looked at the pie chart documentation, I didn't realize it before, and because those mean and standard deviations are all like 0.4, 0.3 something. I have the exact value somewhere, but
Yeah.
I was just but then in FastAI, I didn't see it explicitly mentioned, like that we will scale the images from 0 to 1. So I was wondering if you guys were doing it in the experiments.
Did it say that in the PyTorch documentation you say, Mehul?
Yeah, I'll share a link. Yeah.
Oh, okay.
Yeah, so the guy with his 6 tiles, as I say, when he splits the original images into 6 tiles, he calculates the stats from the tiles that he's created, which gives it like it's a 0.5 mean. I can't remember what the standard deviation is. But yeah, like when I was doing it, I wasn't getting 0.5, I was getting 0.3 for
Okay.
my images that I was making. And so I'd been using 0.3 and yeah, it didn't seem to give very good results. So as I say, when I went to his results, I got slightly better. But then, yeah, like the UNet's using a ResNet with ImageNet, so I've moved to that now, and it seems even better. But yeah, I don't explicitly divide by 255 because I just sort of copied his code or whatever. So I was just doing whatever he did, which is just the fast AI input.
Yeah, first I may be dividing it by 255. I'll look into it. But to your point here, Steve, I actually generated my own, and it was, excuse me, closer to the 0.3 that you're talking about, at
Yeah.
least I think for the thing. So I'll launch a run later today also and see whether using ImageNet stats. That's interesting because I think Raquel had mentioned the same point a few weeks back that maybe
Yeah, he talked
using,
about it a couple of weeks ago and asked did anybody tried it, and
right.
I just assumed that the guy with his original notebook had tried it or whatever, but because of the fact it is using a ResNet, you would think you would have to use the ImageNet stats. So
Yeah, so I kind of try and duplicate that, see whether using ImageNet stats by me increases the score as well.
yeah,
So that would confirm what you're finding as well. Yeah, so as for me, I kind of ran, as I posted, of all of I tried a whole bunch of losses.
right.
I mean, in fact, I can share, let's see, my screen here. Let's see which one. That one. Can people see my screen yet?
Yes. Yeah.
Yeah, so there's like a whole bunch of losses though that I tried out. And in fact, the last one I tried, modified and tried, was the focal loss on, which is, on top of the cross entropy loss, but basically focal loss. And you can see that the private score is fairly high in 0.88. The public score is also 0.88. Private is actually slightly better than public. And that loss is very close. If I go way back down to my very first submission, that is still the best that I've got though, because you can see the private score is 0.884, whereas with the focal loss, it's 0.882. And the public score is in fact slightly better with the original submission, which was just plain old cross entropy with nothing, just
Yeah.
no tweaking. So it looks like, and then, going up, I submitted the dice loss, which had the problem, the bug, or basically it wasn't working for multi-class dice loss. So that was incorrect, the 0.62. I did fix it and posted that code as well, which gave me 0.85. But you can see that the multi-dice, the LOAS, and there are 3 different versions of LOAS I tried. All of those are about in the 0.85 range. The only 2 things which have given me good scores are 0.88, the very first categorical cross entropy loss, and then the focal loss. And I'll get to the, if anybody else has updates, and then to your point, Steve, I'll kind of share the link where I was headed to see what else are the things we can get beyond the 0.88, 0.89 that we are at right now. And I can talk to that once we get updates from other people as well as to where they are or anything else they want to say. But it's interesting because, Lovaas loss is supposed to be a better variant than dice loss, or a more implementation friendly one, or a differentiable proxy, and none of those seem to really help. I mean, they give decent results, but they don't seem to help. And then, as we'll see later when we discuss, it seems combinations of losses is the other thing that we ought to be trying. So that's something else I think I intend to try, because it ought to be easy enough to fire off a run with a combination of losses. That is, 75% categorical cross entropy, 25% multi-dice, or 25% value to focal loss or something like that. So
Yeah, Reckle was obviously saying as well last week about maybe doing the different losses at different stages. So you might start with cross entropy loss and then move on to a different loss to sort of fine tune things.
Yep, exactly. In fact, that's something else that's mentioned, as you'll see in the tricks that people have talked about.
Right.
Exactly that. And in fact, a variant of that they say is run it for several epochs, 20-ish, which is what I'm running, and then pick the metric, pick the model which gives the best metric rather than the lowest loss from your runs, and then take that and fine tune it using I believe many people talk about fine tuning with the lowest loss. So yeah, exactly. Rekel, I think, was mentioning it last week, and that's something else that people have recommended or said that it's worked for them. So, Mehul, anything to add?
I've been mostly going back to my nemesis PyTorch. But I'm getting close, like to do a PyTorch submission.
Okay. So but when you say PyTorch, are you still using the unit model though, or are you building that from scratch as well?
No. I use a shared unit model, but just not FastAI.
Okay. So where are you using the model from, or is that a pre-built model?
Yeah, there's one. Let me share it. It's yeah, this one. Because I saw it. Oh, it's got almost 2,000 stuff. Okay, let me share it.
Are you posting in the chat?
Yeah. Okay, I just put it there.
Yeah. In fact, I was going to point to that one because that seems to be a place where many people are using the segmentation models from.
Mm-hmm. Yeah. So this is I finally understood a little bit more. I completed a short course on PyTorch. like a 6-week course. If any of you are interested, I can share the videos. It's it was quite nice because he went through, like, he started with linear regression, logistic regression, and he's just building the training pipeline in PyTorch,
Mm.
and every time he just kept adding to the same pipeline. So he started
Yeah,
with, yeah, it's very nice. Just to, I mean, like algorithm wise, of course, we've seen everything, but just how to do it in PyTorch.
right. Yeah. If you can post the link, that would be great.
Okay.
If
Yeah.
it's shareable, that would be awesome.
Yeah. It's all. I think it's about, it's 6 lectures and 12 hours, but
Mm.
you can just you can skip through a lot of it because it's for a lot of, that course was called Zero to GANs. So it's like people just starting
Mm-hmm.
out with deep learning. So you can go really fast, and like you
Yeah.
can play it at 2x speed. Okay, share it.
Cool. Yeah, if you can post the link, that'd be great. Even
Yeah,
if,
but
we've gone through fast AI, but still
mhm,
it's awesome because it's more practice
right.
in
Yeah,
different forms and formats helps you keep your familiarity with the tools. So that's
yeah,
great.
yeah. And initially, like, because I used a lot of Keras, I was very familiar with Keras, but I was just really nervous with PyTorch, and just. But after this, now I can make changes easily, like go and change. Like I didn't realize, like ResNet at the end, like the regular ResNet has this average pooling layer,
Right.
and then like I just figured out, okay, how to change it in in PyTorch, and it's actually easy, but maybe I'm just not reading the documentation clearly, like properly, or I don't have the patience.
Yeah, no, so you're dangerous now in PyTorch as we all are.
Yeah. uh, yeah, but
Cool. That's great. Um, so yeah, if you get any submissions going, then we can talk about them in the upcoming
okay.
discussion. Anybody else wants to chime in with their submissions or their trials with respect to this competition? We've been at it for more, Steve, myself, Mabel, and Raquel, who isn't on the call today, have been at it for almost like month and a half to 2 months. So we are probably farther along in terms of getting, which is why for those who joined newly, the thing we typically do is try a bunch of things and submit and work on it for at least a month, 2 months, or until we get to the point where we feel we are running out of new ideas to try. And then we begin to look at, so initially we try just using some basic capability, VDA and stuff, and then subsequently move into developing models and submitting them and getting results scored. And once we've reached a stage where Steve is at, or I'm at, and Rachel was at, and stuff, then we move to exploring what additional ideas we could implement. So until then, we don't look at any of the top end posts, if you will, because we want to try things on our own and also see, for example, where we are coming short and where we are running into issues, and then go to the next step. So with that in mind, if anybody else doesn't have anything, I also wanted to kind of share what I had put together. Let me share my screen again. And this is just there is a link on Kaggle, which kind of summarizes the competition stuff. I'll put that on the link or the chat link after the call. But here I just try to summarize it more for myself, so I can easily identify what things to look at or pursue. Can people see my
Yeah, I can see that. Yeah.
screen? Okay, so if you look at, so I just, I'll post this doc or a Google Doc version of this. just summarize kind of the things there. The link has many more pointers than what I have here summarized, but I just put the 48 plays and then went through the 9th, 8th, 7th, 6th, 5th, copied and pasted here. The things they've done and what type of augmentation they've used, what type of training they've done, and whether they've done ensembling or not. And it's not in any particular format because each person kind of talks about their thing on their own. But what I then did, which is more for my own sanity, because I quickly found that there's so much detail that you can jump to the detail if you want, but I kind of listed and as you can see, are still in progress, still a work in progress. But here are several things that people have tried that I wanted to call out. And of course, one suggestion I would have is maybe we can pick a few of these and try them ourselves, and then also kind of talk to them, much like Rekil talked to, what's the dynamic unit and took us through the code, and then I forget the column segmentation or the
hypercolumns.
Hypercolumns, right? That method. So similarly here, you can see there are like various techniques. So one thing I saw many of these folks allude to is metric learning. So there is a paper on it. There are even a couple of papers on it that I downloaded, but I don't know what metric learning is. And by the way, metric learning was alluded to in even the Human Protein Atlas classification challenge that the number one guy apparently used metric learning. So that would be something interesting to understand and try. Mehul, you have had any exposure to metric learning? Or Steve, yourself?
No, I never looked at metric learning.
Or
Is it
anybody
just
else?
like, is it learning the hyperparameters?
Don't know the first thing, Steve. I downloaded the paper. I haven't yet begun to look at it. But multiple people have referred to it, and I've referred to it being used in multiple segmentation challenges. So I thought, well, that would be probably then a useful thing to learn. Of course, the next thing is something that we all know, different losses. But as I said, some people have referred, besides the losses, individual losses, combining losses, and what you mentioned, Steve, which is training up to a point and then switching for fine tuning. So that's something else that people have tried. And the Google guys, being the Google guys, they blog post and some by-tempered logistic loss. So the other comment that many people have made, in fact, it's there in the link that I'll post of the summary of entries and top entries and descriptions and discussions, is the fact that the data for this competition is fairly noisy, apparently. And that, so this by-tempered logistic loss, again, as I said, I've just, in the last couple of days, just kind of gathered all this and posted. So it's more like I've gone broad and, I'm like a mile wide and not even an inch thick. So I don't know what by-tempered logistic loss is, but that's something else to dive into as well, because apparently it helps deal with noisy data. The next couple, I think some of us, I think Rekil is quite familiar. I'm somewhat familiar. It's been, I did get exposed to Mixup and Mixup with label smoothing. So Mixup is basically combining data input, and label smoothing is more combining the labels and creating artificial noise, if you will, and forcing the learner to become better that way. FastAI does have, does talk in his version 3, part 2 of the course. He talks about Mixup and Mixup with label smoothing. So people have used it in this case in a couple of these, I don't know which one specifically, but they have. So that'll be something else interesting to try. Sorry, go ahead, Steve.
I think we talked about it like a little bit last week. Yeah, like obviously if you're doing categorization on images, you can like stick two images together and sort of say, yeah, it's got these two categories. I think last week we said, like, would it be possible to do it with segmentation, especially because of the fact, like in our segmentation at the minute, every single defect is individual. You can't have like overlapping defects. And so I think we were sort of asking, how can you do mix up if it ends up with like a defect being in the same place as another defect from the other image?
Yeah,
So
that's a good point.
are there actually
Yes.
people have been using it? Yeah.
Yeah, that's what it says. So I'm curious how they used it. So that'll be interesting to figure out.
Yeah,
So
as you say,
I have
I've
not.
only seen it in the Fast AI course, and I've never actually seen anybody actually using it.
Yeah, so that would be a fascinating thing, how they use it in
Yeah.
this segmentation stuff. So
Yep.
they have talked about using it. I have not dived into, as I said, I'm like less than an inch thick on these things this week. I'm just listing them so I can dive into them over the coming weeks. So yeah, that would be fascinating to figure out how they use mix-up or mix-up with label
Yeah.
smoothing in a segmentation challenge. And point 6, which is mix-up with meta-learning. And that is, Mehul, I think you posted this auto-augment thing, which is, again, a Google blog, which talks about, I believe, figuring out from all the augmentation, which are the augmentation, or narrowing down the process of choosing the best augmentations that will help you the most. If I summarize if I recall correctly, is that roughly what you recall, Mayol, of the auto augment post that you had posted earlier?
Yeah, that's right. Because there's just so many augmentations to try, and so the space becomes like 10 to the power like 1000. And this paper, or so there are a sequence of papers on auto augmentation. So maybe I remember now. Yeah, this is an older one, and since then there is a newer augmentation, which even this they refer to as AA, and there's a new one which is a RAND augment, which even narrows it narrows the space down to 10 to the power 2.
I see.
But what you said is right. Yeah, just you use something to figure out what augmentations to do. Like one of the Kaggle competitions I did earlier, where I was trying, you can do things like run augmentations in sequence, and then just say sometimes do this, and sometimes these are my list. I have a subset of augmentations, so select one of these with a probability of 0.5. And then I'm manually picking, and so all of this removes that manual adjusting augmentations.
I see. Yeah, so and in fact, even more fascinating is guiding the mix-up using reinforcement learning. So that's like really getting fancy. Not only mixing up the images, but guiding which ones to use based on some reinforcement learning metrics. So obviously that would mean, having a iota of knowledge about reinforcement learning, which at this point I don't, but, maybe we can use that after we finish the reinforcement learning study.
Yeah.
And then I saw a tremendous number of winners using ensemble of networks. Hello?
Hello?
Yeah.
Yeah. So did anybody have a question or comment?
No,
So,
not me.
so that's another thing to look at. Apparently the number one result, guys, in the salt identification, which is another, I believe, segmentation challenge, had posting about how they used semi-supervised ensemble of CNNs to win that competition, which is kind of a transitionary point almost to the next thing, which I saw referred to quite a bit, which is people seem to be using semi-supervised learning to generate, again, what these are and how they help, I don't yet know, but generating pseudo labels. That's something that many of these top winners have talked about. So that's something else I was curious what are the pseudo labels? How do they help? How do they get generated? Why do they help get increased or better scores? So that's something else that's very interesting, or at least I don't have the first clue about. So that seemed interesting to pursue as well. The other thing I saw, and this is something that many of us have done a little bit of, or Steve has done his own flavor of this, and I'm kind of sticking with what the guy is, what the kernel does by default, which is training on crops of the image versus training on the full size image. Many people, and this is where again it gets into having humongous computing capability. Many people have tried progressive crop sizing and have reported that that really helps them. That is to say, chop the 256 by 256, but then move to 256 by, I don't know, 512 maybe, or 1024, and then eventually get to 256 by 1600. But I also saw enough reports that instead of chopping, if you actually trained on the full size image, that it takes longer to train, but at the same time you get better results. So that I thought was interesting. And then I saw a fascinating post among these top winners, and I just wanted to understand how they did it. Is random crop. So that I thought was fascinating, given that, if you randomly cropped, you would like have parts of defect, and then how do you stitch it together to get to predict for the whole thing? So I just stuck it in there because it's another one of these that even if I didn't duplicate it, it would be interesting to just understand what they were doing.
Oh, that's very interesting, the random crop, because in that short PyTorch course I shared the link to, they basically, like, they're talking about classification, but one of the augmentation techniques was random crop. And I was also very interested by you randomly crop, like say a 256 by 256, and then do the classification.
Yeah, that is something FastAI does. So
Okay.
I can understand random crop in the context of classification, because that by default is one of the augmentation options, in fact, in FastAI.
Okay, I see.
But what I don't get is how would you use random crop in a segmentation challenge where if you crop and you're cropping, and what I have done, or using what the guy has done, where I reuse the code, and in fact Steve has enhanced it. What we do is more a deliberate crop at of 256 by 256 or 256 by some other value on the x-axis, and so on, right? So we are deliberate about how we stitch it together, so we go through the whole image. But if you randomly crop, then you could get part of a defect and not some part. So I'm just interested how it all comes together at the end.
Oh, I see. Okay.
The random cropping, though, is just at training time, is it?
I don't know. I would guess so, Steve. Because
yeah, so like at training time, it doesn't really matter, does it? But yeah, I was wondering that myself, because I'm chopping all the images into 256, and like obviously if you chop the whole image bang in the middle of a defect or whatever, then you're probably like less likely to sort of get the proper prediction on the other side. So
yeah, that's exactly why I'm fascinated by it. When I saw that, I was like, ooh, I need to dig into how the hell are they getting good results doing this.
Yeah, because I noticed the guy, like with his original kernel, he trains on the 6 tiles per image training data, but like then when he comes to do the inference, he uses the original complete images. He doesn't do the final submission based on tiles. So yeah.
Yeah, that's right. Yeah, the inference is for the full size, but and then as I mentioned, I saw a couple of at least cases of discussion of training on full size itself gives you better results than training on chops. So that was fascinating. And then I saw a very interesting post that I thought was also good, because it's a unique technique that might be used for some of these type of problems. Is one submitter among these top 10, I think, builds a segmentation model for per class, because there are only 4 or 5 classes, and then combines them at the end, which I thought was fascinating as well. Which is, you just, like you say, oh, I'm going to detect a single defect, class 1, class 2, class 3, class 4, and then put them together to predict. And then what are the challenges there? And he seems to get, obviously, he's among the top 10, so he's gotten good results. So I thought that would be another, because by doing that, then you tend to avoid this class imbalance problem too, or at least that's what I think. Do you guys agree? Or
Yeah, as I say, I'd briefly looked at sort of the winning solution and what they said they did. They actually used a categorizer on it to start with. So like they split the thing by category, and they used sort of a simple category analysis of the problem to remove all of the test images that they thought didn't have a defect, and then they just applied the segmentation onto the ones that they thought would have a defect. So it was like similar to what you've just said there, except they were doing it sort of upfront, I think, sort of removing images before they came to segment them.
I see. Okay, so yeah, it's kind of a different flavor, but I hear what you're saying. So
Yeah,
essentially, bucketize them and only do the segmentation for those that have a defect.
yeah, exactly. Yeah, and because of the fact that like there's so many images in this data set that
Right.
don't have defects, by sort of simplifying the problem and like using a categorizer in conjunction with your segmentation, then yeah, I suppose they say they got like sort of like a massive boost out of that.
Interesting. That would be a variant that I'll add worth. But if you look at the first, I guess, solution, then but it'll be an interesting, because to me the reason I put these together was also not just for this competition, but in general, what are the learning that we can take away and potentially apply to other things as well.
Yeah, like definitely like what you've said there about your point number 12 about an ensemble of models. Pretty much every single competition I've taken part in, that's what all the winners are sort of ensembling sort of 5, 6 or more models together to get the final solution. And every single one of them, it's like sort of taking all the best models. But I think there are like a whole sort of variety of ways to combine results, which
Yeah, and
is
it's
a whole sort of subject in itself.
yeah, exactly. But some of that is annoying too, because you need so much compute to put all of those together. I mean, you get, it takes, as we've discussed, even if you don't use Kaggle, it still takes 8-10 hours to train the thing. Sometimes they've talked about 24 hours training, I think, the winners. And then that's for one model. And then they do, as you said, ensemble 7 or 9 of them. So that's like, 9 days of runs.
Yeah. Sometimes though, like yeah, like obviously like in this case here, you've got like people's submission files. So if you just get the submission files, they've got like the run length encoding of the mask areas. And so you can just sort of take the mean of the mask areas and like ensemble with those, as opposed to actually sort of running the kernels themselves. You just take the output of the kernel and use that, so you don't have to train the whole thing again.
Okay. So you just ensemble the results of the runs rather than running them. Okay, that's cool.
Yeah, exactly. Yeah.
Yeah, that'd be cool. Interesting. And then there are some links. I think the links are there in the rest of the documents. I can show you right here, for example, the catalyst. And then the segmentation model is exactly the one that Mehul just pointed to. And these are just a variety of segmentation models that the guy has in GitHub, which uses a bunch of different encoding, RESTnet, Inception, blah, 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 take your pick, efficient net, and all made into, I think, units and a variety of different segmentation models that you can use. And then the DVC seems to be something like Jovian, in the sense that it's, what would you call it? It's like software management for Kaggle data competitions. config
All right.
management type of tool.
Yeah, because I've sort of had to give up on Jovian because of the fact I've like gone back to using Google Colab or whatever, and Jovian doesn't work with it. And I saw there, you see, when you had your list of your Kaggle entries, it would be so good if you could actually put labels onto each Kaggle entry to have some notes on it, but it doesn't allow that. So if there was something that allowed you to sort of label each Kaggle entry, it would be good.
Yeah, I've
so
heard
this.
this. Oh, sorry.
Go ahead.
I've heard this weights and biases. That's really good for doing that, Steve. But I don't know if it works with Kaggle, with Google Colab. But I heard a lot of good things about weights and biases, and it has for like keeping track of your experiments.
Is it just the same as Jovian, is it? Or similar to Jovian?
It's similar, but it has some more features. They talk about parameter sweep. So, like how you might be changing your learning rate or dropout, or it has some Bayesian, it has some more, like Jovian was just just logging, but weights and biases has more algorithms. So it has some Bayesian algorithm to do like a random search of your parameter space. I haven't worked with it at all, but it's a very active community. Like we have our Slack community. They have one too, and it's just too hard to keep up. But if I try that, I'll let you know if it works. Yeah.
So I mean that. So there are like as I said, different things. And by the way, I know Rakel would probably know the answer because I think he has tried it, but I haven't. So I had a question for myself on item 11 of whether the feature pyramid network is actually the same as UNet as Jeremy alludes to, or is that different? Because many people in the competition have used feature pyramid networks. You can see even on the right, it says FPN efficient net times 2. So I'm just curious whether, my understanding based on what Jeremy said was, it's just a fancy name for UNet that people have to come up with a separate name for it. But then if you see here on the right, I don't know which particular submission this is, but they have Ensemble 7 models and they're using UNet and they're also using FPN efficient. So I'm just curious whether that is accurate understanding that FPN is the same as UNet, or are there reasons why it's different? So I made a note to myself to chase that down. New libraries 13, some post-processing, and I know Steve definitely has talked about it. We discussed it very early on of why the metrics guide us towards kind of not, or in this competition, why it's important not to predict false positives because it ends up hurting you. And so that there is a bunch of techniques that people have tried. There's reference to triple thresholding, which again goes back to what the people or the competition winners of the TGS salt identification challenge have done. Beyond that, I don't know. As I keep repeating, I still have to dive into the details of any and all of these. There's something that people have done called label threshold. Of course, we discussed what pixel thresholds are, which is to say, hey, if there aren't enough pixels, then don't even tell me the class exists. And things of that nature. So there's a bunch of post-processing after the segmentation is done. A little bit of it, I think we are doing already if we are using the kernels, but there's much more that people have done. So that's interesting to dive into as well.
Yeah, again, I noticed, like we use like a really sort of simple thresholding where if there's not like a certain number of pixels across the whole image, across all the defects, then we sort of take the image out. Whereas again, I saw the winner, they do it on a per defect basis, because like obviously certain defects are much more common than others, and so yeah, they've got like a weighting per defect, and so they sort of apply it on that level, which sounds like a lot better.
So that's probably what label thresholds are, that you would probably have a threshold per class.
Yeah, exactly, yeah.
Interesting. That'd be fascinating how they determine that.
Yeah, I don't know how they decide what the label is or what the threshold is per class.
Right. Because like you said, I think the thing we're using right now is just like a crude one number fits all solution. But
yeah,
how do we implement a per class, and how do we determine what that number is per class? That's the interesting learning there. And then a couple of them seem to be using slightly different optimizers and schedulers. Like I have seen RADM, and in fact, I believe the RADM is what is the default in FastAI 2. I haven't dug into it, so I thought I'd put that there so I can spend some time understanding how this rectified ADAM is different from regular old ADAM. And there's a mention of ADAM W, and then the GNOME scheduler. I don't know what those are either. And Rekil actually talked about this accumulating gradient, which is basically because you have a small number of, as you continue to drop batch size, then you need to accumulate gradients, or else you don't get good enough results. And so if, as he rejoins, I might request him to talk through an implementation of accumulating gradients.
Yeah, I noticed that, what's it called? Is it Zachary Mueller? There's like some guy that does like a sort of set of YouTube videos on the new FastAI library.
Yes.
And yeah, like within his UNet, he's using some different type of optimizer other than Atom. Yeah, so like he's taken the whole sort of FastAI 2 version or whatever and applied like a whole load of new stuff in that.
Yeah, so in fact, FastAI 2 uses RADM and some other, instead of ReLU, they also use a different rectifier or different, what's the word I'm searching for?
Activation function.
Activations, yeah, than ReLU. So that's something, I marked it, but I haven't dived into it, but there'd be a good reason now to go into it and figure out what it's doing. And talking about computing power, people have done everything from 1 to 5-fold CV. I mean, 1-fold CV takes 8 hours for me, so it's like joy.
Yeah.
I have a basic question about like when in classification you're always freezing and unfreezing, and here so did people do something like that, or they don't mention like in segmentation?
What the kernel that we are using and the base kernel that the guy is using FastAI, it does freeze and unfreeze. It freezes kind of the decoding layer, the top 2 layers or something initially, and trains so that you're just training on, the output and stuff. And because the encoding part is already trained on ImageNet, right? So the frozen thing just trains the decoder. I forget how many layers of the decoder. Memory serves me, it's just the top 2. It may be more. I don't recall off the top of my head, but it's just the decoding some layers. And then that's done for anywhere from 2 to 4. I think it's actually 4 as a default setting in the runs we do. And then train the whole thing for about 15 epochs more, unfrozen.
Okay, thanks.
But by the way, interestingly, one of the things, and I didn't put it here, I'm just talking from memory as I plug through these, some of them seem to just keep the encoding frozen except for the batch norm layers. That's something I saw, which I thought was fascinating as well. That is, because the encoder on the unit is already trained on ImageNet, you just keep it frozen except for the batch norm. And I didn't quite figure why they did that way, but if you dig into one of the links, about in the details in the documentation. It's there. And then, as I mentioned earlier, ruling out of false positive is the key to getting high scores. So there are a variety of techniques people have used, some of them in thresholding, but other means as well. That's something else that's interesting because you could use that technique wherever you wanted to kind of eliminate false positives. So I thought that is something else worth identifying and understanding. And the last is augmentations, and there are most people have used just horizontal flip and a couple of other choices, but one guy also talked about, and I thought this is again very interesting, where he has a custom augmentation for this particular challenge where he randomly blacks out defects and labels accordingly to he's blacking out the defects, and then when the defects are completely blacked out, then he changes the label because the label has to disappear. Sorry, somebody mute. It's a lot of noise on the...
Yeah, sorry.
So that's, I thought that custom blackout of defects and labels was fascinating as well. Any comments? Or I mean, that just shows you this huge number of things to try and also learn to do.
That's really good. Like everything you've put together there. Sorry, I've got one question. You see, like you had like the list of libraries and stuff that people were using. What is the Catalyst one? Sorry, I'm not familiar with it.
Yeah, I haven't looked at that one either, but
is it again similar to Jovian, or is it something completely
different?
No,
it's actually more of, oh, now I recall. The guy was referring to Catalyst to say he was able to experiment with a whole number of models very quickly. So that's my recollection of what it I have some restrictions on my computer. Okay. That's interesting. But yeah, I haven't checked it out yet, Steve, but that's my recollection of where the guy, he said that Catalyst was a new library that really helped him run a bunch of experiments very quickly.
Right.
So Mehul, are you familiar with this one?
No, this one I'm not. I just remember one thing from the Adam W. I remember some Kaggle discussions where they were saying that Adam versus Adam W. Like Adam, you normally go with point as like 1 e to the power minus 4, right? The starting learning rate, that's the default. But people were saying Adam W converges much faster, and so it saves you a lot of compute as just a practical. But I haven't experienced that myself, so that might be interesting to see if Adam W converges faster than Adam. And if I find the paper, I'll share it on. I think that it came from a research paper, and if I find it, I'll share it on the channel.
Okay, great. Yeah, which actually reminds me, since we're talking about sharing on the channel, and I'll post the Google Doc. So if people want to add to this, feel free. I'll post it as a Google Doc rather than a Word doc, so it can be edited by other people and added to and stuff. But one other thing, since we're at least right now, a small number of people who are repeatedly, and continuing to participate in Kaggle, one of the things I signed us up for is the TWIML AI community is thinking of gradually or over time moving to discourse, much like FastAI uses discourse rather than Slack. One of the motivating factors being that, a lot of things we post tend to disappear in Slack, whereas in discourse, you can kind of create a wiki page. Much like FastAI, you can retain a lot of what you post and can move on to, like if one competition ends, all of the data relating to that competition that we have discussed and posted is all available there. And then we move to a different one that can go accumulate in a common area. So I volunteered us as a group. So you might see, just a heads up, some communication from TWIML staff about what we might as a group need to do to, we'll kind of be the early migrants to discourse. The positive on that is going to be that, we'll get to easily refer to the links that Mehul or Rachel or Steve or many of the other participants post, and continue to benefit from using or access to those links. The slight downside may be that we have to be conscious about being on both Slack and that for a little while until everybody is switched over.
Yeah, no, that sounds good, to be able to sort of keep things in one place and be able to access it quickly, because I know like a lot of people put up links and then by the time I sort of come to think about it, I can't find them anymore.
Yeah, exactly. That's a very frustrating problem I've had to think, oh, Mehul posted something, and then you have to scroll and link, and it's like, and sometimes you don't even remember that Mehul had posted that, and if it's all there, you can just go and with a few scrolls get to it, but you don't even know it exists in many cases. So hopefully that's something that this course which will help us with, but just a heads up for us that we'll potentially get some guidelines on how to migrate to that and use that and stuff in the coming weeks. So bunch of stuff to try, and as I said, I'll post it on Google Docs. If you're interested in pursuing any one or two of these, maybe flag them on Slack, which ones you're planning to try or read up on, because then it'd be great if you dive into it. Then if you can also come back and share what you learned and how they've actually implemented it, even if you don't implement it yourself. That would be kind of awesome, because I think there's, as you can see, there are already like at least 15 different things to try or learn, and many of them that I don't have the first idea of what it does or why it's good or how to implement it. So it would be great if we all picked one or two and either learned about it from others' implementation or tried it ourselves even better, and then talk about it in the coming weeks. And hopefully our scores will get better too, because the reason to do all this is to see whether it actually has any impact.
Yeah, like the scores I've been getting are very similar to yours, whereas the best scores I had were just when I took the guy's basic model. I just stuck with that. Since I've started playing about with his model, my scores have got worse. So yeah, I was going to sort of like try and go back to his original model and see why those scores are better than mine. I think it was that when he, as I said, like when he did the inference, he used the full image, whereas I've been using tiles of images. So yeah, so I wanted to go back there. But that the FPN sort of equivalent of UNet, I've never even heard of that one. So yeah.
Yeah, it's a paper that I think very early on when we discussed hypercolumns, I also pointed to the paper. I'll post that link if I had not done so earlier. It's called Feature Pyramid Network. And I know I specifically heard Jeremy poo-poo it, saying, oh, here come these guys who are just using UNet. And instead of pointing to the paper, they invent a new name and give it. It's actually the same guys, I think, originally the guys from Berkeley, and he, if I recall, I might be wrong on this, but I thought the hypercolumn guys also did the feature pyramid, but I may be wrong about that. But anyways, feature pyramid, I didn't dig into it primarily because Jeremy's brushing aside of it said, okay, stick with dynamic UNet and you get what most of feature pyramid is. But now that, people seem to be using it separately from UNet, as part of an ensemble, I just want to see whether it's different enough from UNet, and is there something that I'm missing by following Jeremy's, it's no big deal, quick analysis. I'll post the link to that paper.
Is it in the other link that Mehul put up there about the segmentation model library thing? Is FPN within that?
I haven't checked that, Steve. We'll look at that. I would imagine that would be one of them, but I have not looked at it yet. Okay, so that's what I had, and it's obviously a lot of reading, learning, and trying that's captured on that sheet. So a lot of interesting things to try and learn from and see whether it helps us.
Yeah, no, that's
Anything
really
else?
good.
Go ahead, see.
Yeah, no, that's fantastic. Like what you've done there. So like, I'll look forward to see that and work my way through it.
Yeah, that'd be great.
Yeah,
Okay,
it looks. Yeah, thanks, Srinivas. Yeah, thanks
sounds
to you.
good. Let's